Hello guys, مرحبا فيكم جميعا بفيديو جديد. In this video I'm going to talk about the second and higher order partial derivatives. بهذا الفيديو أنا راح أشرح لكم عن هذا الدرس تكملة للفيديو القديم. وقبل ما بلش الشرح راح أحاول أعطيكم شوية مراجعة لبعض القوانين في التفاضل اللي هي ال derivative. Before I start explaining what this lesson means, I'm going to give you some review, some rules about the derivative, and because the university is about to start and you need to have some review about some rules. So let's start. Let's start with rule number 1. It's called the constant rule. القاعدة تبع أي رقم ثابت مشتقته اللي هي بتكون صفر. The derivative, for example, for any number, let's say a constant c, like the derivative of 1, 2, 100,000, million, billion, zillion is equal to 0. This is rule number 1, okay? Keep it in mind, okay? Let's make it much bigger a little. Okay, this is better. So, as I said, this is rule number 1. Rule number 2 is the product rule. The product rule, it's written like this: f prime of x times g of x plus f of x times g prime of x. This is rule number 2. Okay, let's keep it here. Rule number 3 is called the quotient rule. لما بدك تاخذ مشتقة بس عن طريق القسمة وليس بالضرب. The quotient rule is g of x times f prime of x minus f of x times g prime of x over g of x square. So this is the product rule and this is the quotient rule. Pro and co. Keep it like product and quotient rule, okay? Let's make some space here. Okay, let's make some review about the chain rule. The chain rule is the function f prime of g of x times the inside g prime of x اللي هي قاعدة السلسلة. Let's take some example if you find it difficult a little. Let's use, for example, sine of x. Okay, the derivative of sine is cosine, but why or how is cosine? Let me explain it. Here is f prime, which means this function is sine. So the derivative of sine is cosine, okay? Sine. The inside, we keep it the same. So we write here x. And then we take the derivative of the inside. So the derivative of x is 1. So cosine x times 1 is still the same. Okay, so this is how the chain rule is. Let's make also, let's take some rules about the trig functions for the sine and cosine. So I said here the sine of x is equal to cosine of x, and the derivative of the cosine is equal to minus sine of x. Let's take the tangent, for example. The tangent of x is equal to secant square of x. Let's take the cosecant. Cosecant of x is equal to minus cosecant of x times cotan. and the cotangent of x is equal minus cosecant square of x. The last rule for the trig function is the secant. The derivative for the secant is secant x times tangent x. Keep it in mind. Don't forget it. It's really important to make some review before you start, because sometimes you might have some partial derivative with trig functions. So it's really important to remember it a little bit. Last review I will talk about is the exponential functions. It's really easy. The derivative of the e to the x is the same, e to the x. Let's write a to the x. It's the same, but a is a variable. Here it's a constant. So the derivative for a to the x is a to the x times ln a. The derivative of the ln of x, or ln x, is equal 1 over x. Here is number 1, number 2, number 3, and the last rule I will talk about is the logarithm. The log a x is equal to 1 over x times ln a. Okay? You can write it in a notes or something. So I will leave here like 1 or 2 seconds, or you can write it, or I delete it. Okay. So let me delete here to start my subject right now. Okay. The second and higher order impartial derivative, it means that sometimes you can make 2 times partial derivative. Like in the last video, we knew how to find the slope, we knew how to find the partial derivative with respect to x and y, with a point or without a point. But second and higher order partial derivative, it means that you have many ways or many times you can find the partial derivative in. For example, in the last video, we knew how to find the partial derivative with respect to x and with respect to y. But in second and higher, I can use, for example, with partial derivative with respect to x, I can also find it with respect to x. And here also I can find it with respect to y. And also, can I find partial derivative with respect to x with y? And can I find the partial derivative with respect to y with respect to x? Yes, you can. And right now, or in this video, I will give you 3 examples, 2 normal examples functions, and 1 with trig functions, so you can deal with it, or how you can deal with it. It's simple, just focus with it. So what this means, before I delete it, let me tell you something. There is something called Schware theorem. Schware theorem said if f with respect to x and y is the same value as f with respect to y and x are equal, which means they are continuous. Sometimes maybe in a test or midterm or final, some question might tell you, show, is it continuous or not? So if this question came, you need to find the f with respect to x and y, and f with respect to y and x. Okay, so this is what Schware theorem means. Let me get to the point and give you the examples so you can understand without talking a lot. Because some people want examples more than talking, you know. That's simple. I love that too, actually. Okay, let's start my first example here. The first example said f of x comma y is equal to 5x cubed y times y to the 4th minus 2x squared times y plus y square, this is y, not 4, be careful, y square plus x and plus 1. So to find the fxx or f2y or fxy or fyx, first step you need to find the partial derivative with respect to x and the partial derivative with respect to y only. Just deal with everyone alone and then I will show you how you can deal with it. So let's find the partial derivative with respect to x first. So here we're dealing with x, not with y, and also notice that we're dealing with y as a constant number or variable because we're dealing with x right now. We're taking with respect to x, not with y, okay? As it's shown here. So 5 times 3 of 3 times 5 is 15. X, 3 minus 1 is 2. 15x squared, and y, we keep it the same. Minus, here we're dealing again, as I said, with respect to x. So 2 times 2 is 4. X, 2 minus 1 is 1 times y. And then plus y squared is 0 because it's a constant. And every constant is 0. And then here there is x plus 1. And 1 here, there is 1 here. It's a constant. It's the same as the y squared. So also it's a 0. Let's take the second function, f with respect to y. Let's deal here from the original function, let's deal with the y. So 5 times 4 is 20. 20x cubed. Y, 4 minus 1 is 3. So 20x cubed y cubed. Minus, here is x squared minus 2 x squared y. So we're dealing with y here again. So y here, the derivative for the y is 1. So what's left here is minus 2x squared plus here y squared. So it's 2y, and then plus 0 plus 0. So we don't have to write anything else. From here, let's take, for example, the easiest thing, f with respect to x with respect to x. So what this means, we need to take from this equation the partial derivative with respect to x again. Okay, so let's deal with it here. Okay, make it black. Okay, so 15 times 2 is 30. X, 2 minus 1 is 1, and then y to the fourth is the same. We're dealing with respect to x. It's the same as you're dealing with respect to x here from the original function. It's the same. You're dealing here only with x. And then minus x here is 1 for the derivative. So what's left here is minus 4y, and 1 here is 0. Okay, so let's deal, for example, with f with respect to y with respect to y. So from this equation, we need to also make another derivative with respect to y only. So with respect to y here, 20 times 3 is 60. X cubed. Y, 3 minus 1 is 2. Minus 2x squared is 0. So we don't have to write it because we're dealing with y, not with x. And then plus 2y, the derivative for y with respect to y from this equation is 1. So what's left here is 2. Okay, so let me make some space to talk about the fxy and fyx. Let's delete those. We don't need them. Okay, black brush. Okay, if we want to deal with f with respect to x with respect to y, which means I need to take the partial derivative with respect to x, which means this function, I need to take its derivative with respect to y here, as it's shown here. Okay, so we need to take from this function, or we need to make a derivative from this function with respect to y, not with respect to x. Okay, so equal, let's try to do it. 15 times 4 is 60. X square, not minus 1. We're dealing with y, remember? Then y, 4 minus 1 is 3, minus, we're dealing with respect to y, so minus 4xy. So the derivative for the y is 1, so what's left here? Minus 4x. And the same here, the same concept. Let's deal with f with respect to y with respect to x, which means from this equation I need to take another derivative with respect to x. So 20 times 3, 60, x square, and then y cube, and then we're dealing with respect to x, right? So minus 2 times 2 is minus 4x, and then plus 2y is 0 because we're dealing with respect to x. And notice here the answer that we've got here, they have the same answers. F of x, y, and fyx, they are equal, which means they are continuous function. This is the concept of this equation, or the second or higher order partial derivative. Okay, let's take another example. Second example, you can pause the video and try it, and then you can see the answer if you like, or you can continue and see the answer with me. You can do whatever you like. So let's take the second example. Black brush. Okay. The second example, f of x prime y, comma y, is equal to x cubed plus 3x to the fourth times y square plus 2y to the fourth. So we need to do the same steps. First step, we need to find the partial derivative with respect to y and with respect to x alone. So here, we're dealing with respect to x here, we will get 3x squared. The derivative for x cubed is 3x squared. 3 goes to here, and 3 minus 1. It's the power rule. Plus 4 times 3, 12. X, 4 minus 1, 3. Y squared plus 0. And then f with respect to y is equal, x cubed is 0, plus 2 times 3, 6, x to the fourth, times y, 2 minus 1 is 1, plus 4 minus 2, 8, y cubed. So this is the first step. Okay. The second step, let's take the easiest thing, f with respect to x with respect to x. So from this equation, we need to deal, or we need to make another partial derivative with respect to x again. So 2 times 3, 6, x to the power of 1, 2 minus 1 is 1, plus 12 plus times 3 is 36 times x, 3 minus 1, 2, y squared plus 0 is 0. Let's take the other function, f y with respect to y. So it's the same concept. We're dealing from this equation again with respect to y. So here 0, it's still 0. We don't have to write it. Here there is sorry, give me a minute. Here it must be 6. Okay. So here, what's left here is 6 x to the fourth, because with respect to y, the derivative for the y is 1, so what's left here is 6 x to the fourth. And then plus 3 times 8 is 24 y squared. so this is the final answer for those, but right now we need to find the f of x with respect to y and fx with respect to y, or fxy and fyx. So fx then y, so we need to deal with this equation. We're dealing with respect to y, remember. So here there is only x, so it's a 0. So 12 times 2 is 24x cubed times y to the 1. 2 minus 1 is 1 and 0. And f with respect to y and then with respect to x. So we're dealing from this equation, we're dealing with respect to x, remember. So this one is 0. We need to deal from here. We're dealing with x, remember. So 6 times 4 is 24. 24 x, 4 minus 1 is 3. And then times y. And here there is 8y cubed. It's a 0 because we're dealing with respect to x, remember. So this is the final answer for the whole equation. And also again, remember, notice that those have the same answers, so which means this function is a continuous function. Okay, خلينا نبلش بالمثال الثالث اللي هو آخر مثال بالفيديو. Let's start with the last example for this video. This example, as I said, is about the trig functions. I wrote it here. I hope it's shown. It says here f of x comma y equal y times tangent in brackets x times y. So as I said in the first step, we use the f of x and we use the f of y, f with respect to x first and f with respect to y. So starting with respect to x, okay, so dealing with respect to x in this y, or in this function, we don't have a x here, so we don't have to use the product rule. So we just use it with nothing, with no the product rule. We only use the chain rule. So the chain rule said f prime g of x times g prime of x, which means let's take the tangent here. The derivative for the tangent is secant square, and then we write x and y the same as it said here, and then we take the derivative for the inside with respect to x, remember. So dealing with respect to x, what's left here is y, so the derivative for the x is 1, and 1 times y is y. So what's left, the final answer, y times y, we can combine them together. So y squared times secant square x comma y. Okay, let's delete this one and let's move it to the left. Okay, let's find, for example, right now the f of x with respect to y. Okay, so from this equation we need to deal with respect to y, not with respect to x. So notice here we have y squared, and inside this function we have y. So what we need to use here, what is it? Yeah, it's the product rule. So the product rule said I need to choose first one, I take its derivative, and the second one I write it the same, and I write plus, and I do the opposite to the other function. So let's, for example, let's start with the y square, for example. So I will write 2y, the derivative for the y square with respect to y is 2y, and then I write secant square xy is the same, secant square x times y, and then I write plus. Then I write y square is the same, and I take the derivative for the secant. So notice secant square xy, it can be written like secant xy times y and then square. So the derivative for this equation, this power rule can goes to the here, and then I write 2 minus 1, and I take the derivative for this one, I leave this one the same, and I take the derivative for the inside. So let's see how it goes. Okay, let's leave it. So we write times 2. So I can write 2 here in the front. So this 2 goes here, okay? And then times, the derivative for the secant is what? Is secant xy, because inside there is xy, and then times tangent xy, and then I write, or I find the derivative for the inside. Inside we have x and y, and we need to take with respect to y, so what's left here is x. So y, the derivative for the y is 1. 1 times x is x. So this is the final answer. I can make it in more appropriate way. I can write 2y times secant square xy, and then plus 2 times x times y squared secant xy, and then times tangent xy. Yeah, and this is the final answer. As an exercise for you, I will leave the other 2 functions that I didn't find. You can find it, and I hope you can find or reach your way. It's really easy, it's not that bad. Just do the same, and uh, remember the trig function that I wrote in the first derivative rules. Remember them, and yeah, everything will be easy, hopefully. So as an exercise for you, you can find the you can find the f with respect to y, and you can find f with respect to y, and then with respect to x. Okay, let's find, before this video finish, let's find the fx with respect to x. That's okay. We found f with respect to x, and we found f with respect to x, then y. Okay, let's find it f with respect to x with respect to x. Okay, so we need to find with respect to x. Here there is a y square, and here there is a what is it called, x. So we don't have to use the product rule. Okay, so let's write with black. We can write this secant square, as I said, it can be written in secant square xy square. So this 2 can goes to the front here. So we can write 2 times y square, which is this one, and then secant x y, and then times secant xy, because we took the derivative for the secant. It's secant xy times tangent xy, and the derivative for the inside with respect to x, remember, is y. X is 1. 1 times y is y. Yeah, we can combine like terms. We can combine 2y squared with y, and secant xy with secant xy, and tangent, it's gonna be alone. So we can write 2y cubed secant, this is a secant square xy, and then times tangent xy. Yeah, and this is the fx with respect to x. I really hope everything is easy. Thank you for watching, and yeah, I wish you the best. If you have anything or any question, or I don't know if you may have or find any mistakes, if you have any mistakes, just comment down below, or you can send me via my email. It's gonna be in the description. بتمنى كل شيء كان واضح وسهل، وإذا ما حدا فهم شيء يكتب بالكومنتات، وبتمنى إني فيدكم، وبتمنى من الكل النجاح والتوفيق بهالمادة. شكرا جميعا.